Hi dear students, once again welcome to Electronics Lecture Series. Ashok Jadhav welcomes you. In previous video we have studied how to write assembly language program for addition of 8-bit numbers, and we assume that the two numbers were given in sequential memory location, and we stored the result in subsequent, that is the next memory location. Now today I want to modify that program for 8-bit subtraction. Here also we are going to assume the two numbers for subtraction given in the memory location in sequential, that is location 1, location 2 and location 3, and the result is again to be stored in memory locations. So let us study how to modify that program. Friends, let us consider example assembly language programming example for 8-bit subtraction. Let us assume that the two numbers are given in a memory, that is RAM, having address CA23hex, and the next number is given in CA24hex, and then the result is to be stored at next location, that is CA25, right? Here I have shown symbolically there is a microprocessor, and you know that the numbers cannot be processed in the memory itself, so you will have to access memory. मेमोरी से n1 को निकालना होगा. So get this number into accumulator. How to get it we shall see. Then subtract the second number from the first number, right? And whatever result, in this case the result will be difference, because you are subtracting second number from the first one, and that result is stored. So the flow chart will be something like this, that is load memory pointer HL, because we want to access that location where our first number is there. So load HL pair with CA23 hex, that is address of the first number. So this is the first step we have to take. Then get this first number into accumulator from memory. At this step you have to search appropriate instruction with which you can load the accumulator from memory. Then we want a second number to be subtracted, and therefore pointer, memory pointer, that is HL pointer, is to be incremented. So it will find the next number, that is at CA24, and that is N2. So we updated here. We can update the memory pointer, and then we wish to subtract this second number from the first number, and again you have to choose your appropriate instruction for subtraction. So at this level the result will be ready in the accumulator, and then we wish to store the difference, that is the result, in a next location. And for getting the next location you have to update memory pointer, because whatever you want to store or get the number from the memory, HL always point the memory location. Therefore here again increment HL pair to get address to store the result, right? And then once you address is reading HL pair, we want to store the result at location, that is next location CA2H. This is the nature of, you can say, the sequential steps, you can say, and we call it as a flow chart. So let us consider flow chart along with the assembly language program. So here statement of the program, that is write an assembly language program for 8-bit subtraction. This is a statement, and assume your own addresses for numbers and for storing the result और numbers के लिए memory के location assume करना है. So here we are assuming 3 memory locations, say CA23H, CA24H and CA25H. So these 3 numbers we are assuming for storing the data and the result, and the flow chart as we have seen. So let us consider appropriate instruction for each step given in the flow chart. So consider this load memory pointer HL. HL में हमें पहले नंबर का एड्रेस लाना है, and the instruction required will be We have seen this is the format of assembly language. No labels in this program, only mnemonic and operand and some suitable comments. Once again, I am repeating that comment should not describe this instruction. Comment should just make a point that what is the purpose of this instruction in this program. ये इंस्ट्रक्शन अपने प्रोग्राम में अपने काम के लिए क्यों यूज़ किए उसका यहाँ रिजल्ट रिफ्लेक्ट होना चाहिए. दैट इज द कमेंट. See here, LXIH CA23 hex. That means load immediate. Some register pair is HL with what 16-bit quantity is given CA23. So 16-bit address is gets loaded into the HL pair. So HL pair is ready now to point that first number, and therefore we want to get that first number into accumulator, and therefore the instruction is move to accumulator from memory. And when capital M is there, you know that the location, memory location, always pointed by HL pairs. So with this instruction you will get first number into accumulator. Now we want to access next number, and in order to get next number, what we do, we should increment, update the pointer, and for that I and X increment HL pair. So memory pointer is incremented and it is pointing now say CA24. पहले क्या था, CA23 था. Now it has become CA24 because it is the address where our next number is residing. And then now it is ready, pointer is ready. So subtract M, subtract memory, and we have studied this instruction. What happens with this? Content of memory location whose address is given by HL pair are subtracted from the accumulator, and the result goes into the accumulator. So at this level, second number, that is from second location, will get subtracted from the accumulator, that is the first number, and the result, that is subtraction, that is the difference between two numbers, is now available in the accumulator. And now that result is ready and we want to store to the next location, and once again for that we will have to update the pointer, HL pointer, and therefore increment HL pair. So HL was CA24, upon incrementation it will become CA25. That means HL pair is ready, pointing the location where we want to store the result, and our accumulator contains the result, and therefore instruction required here will be move to memory from accumulator. See, I am reading move to memory from accumulator. इस इंस्ट्रक्शन से उल्टा, यहाँ मेमोरी से accumulator था, यहाँ transfer from accumulator to memory, because we want to store the result generated in the accumulator, and it will be stored at CA25H. And as usual, the last instruction is always HLT, that is halt, stop the processing. So these few instruction 6 to 7 instruction, using this 6 to 7 instruction we can subtract to 8-bit numbers. Let us consider example for this assembly language program. So let's consider previous slide. See that suppose if you give some sample data at CA23, that means in this memory location CA23, let us provide the data FC, first number. Now provide N2 as a 54, content of CA24 as 54. So if we assume, and if this data is provided in these two locations, and if you execute this program, after execution, see what will happen. This FC will go to the accumulator. FC in binary looks like this: 1111 1100, and then when next number is added, that is 54, in binary 0101 0100, and when these 8 bits are subtracted from this 8 bits, the result produced in binary is 1010 and 1000, and if you want that result back into the hexadecimal form, so it is A8, and therefore after execution of this program, particular program, you will get the result as A8, and where it will go, CA25. So practically you can verify the program written by you ये लिखा हुआ प्रोग्राम ठीक है कि नहीं है, एग्जैक्टली रन हो रहा कि नहीं हो रहा, इसके लिए हमें सैम्पल डेटा देना पड़ता है. दिस इज कॉल्ड द सैम्पल डेटा एंड यू गेट द रिजल्ट. दिस इज हाउ कैन वेरीफाई our whether the program written is correct or not. Okay, students, I hope you have understood how to write simple assembly language program. Today, we have assumed that the numbers that are operands given in memory location and we store the result in memory location. Many times, these operands may be provided in CPU register, may be available in CPU register, or the operands, you may have to consider your own operands, your own numbers, and we want to perform on them. And for that, you will have to choose appropriate instruction for that. Think over this. So let us stop here. See you next time. Bye.